다음으로 비전 체인의 최고 기술 책임자 CTO라고 그러죠. 고쿨 알렉스 CTO님은 영상에 지금 보고 계시는데요. 이번 행사에 정말 오고 싶었지만 오시지 못했습니다. 그래서 줌으로 영상으로 최신 기술 발전에 대한 프레젠테이션을 듣도록 하겠습니다.
Next, it is time to learn about the latest technology development. The Chief Technology Officer of Vision Chain, Google Alex, supposed to make a presentation on this. But unfortunately, today's CTO Google is not able to attend the event. So he's greeting us through online.
그럼 고쿨 알렉스 CTO님을 줌으로 연결되었나요? 네, 연결해서 지금부터 발표를 듣도록 하겠습니다.
We will connect to the CTO of Alex Google via Zoom for his presentation.
Thank you. Hello friends, I am delighted to present the formidable features and future-forward capabilities of Vision Chain. Vision Chain is designed as a modular blockchain protocol powered by the creative convergence of state-of-the-art cryptographic primitives, novel consensus algorithm, and scalability engineering elements. It has evolved through countless iterations of research and rationalization. Hence, it is a really exciting experience to deep dive in core components of this protocol in this forum. So let us see the main contents of the presentation. We will begin with an understanding about the core components and the feature highlights. And then we will first begin our exploration with a journey through the interoperability approach by understanding the zero-knowledge proof approach and the log contract system, interoperability layers and oracles. Then we will go to the intent integration method where we deliver intelligent experiences. And afterwards, we'll try to understand how Vision Chain is made quantum safe through the application of post-quantum cryptographic primitives. And then we will try to understand the fairness and fast-based consensus algorithm and how it is combined with our sharding techniques. And we will summarize the technology architecture of Vision Chain. So let us begin our journey with an understanding of the major highlights of Vision Chain. Vision Chain is designed as a modular blockchain montage. That means it is a creative convergence of a cross-chain, cross-layer interoperability approach powered by chain intersection proofs, which is radically very different from the existing cross-chain, cross-layer interoperability approaches of various chains. And it uses state-of-the-art combination of account abstraction and an intent solving system coupled with knowledge graph-based semantic experience to make sure that the accounts, the blockchain accounts are very powerful, very user-friendly, and intelligent. And the Vision Chain comes with a rapidly scaling mempool designed to address network congestion and provide parallel processing capabilities. And this uses a secure combination of shuffle sharding and state sharding technique that produces storage proofs. Then Vision Chain is engineered with a quantum safe consensus algorithm, which is proven based on cryptographic techniques that leverages single secret leader election. And the blocks are generated using a novel technique known as Verkle trees, which produces very efficient and very scalable blockchain states. And there are a lot more innovations inside the Vision Chain, which we will try to understand in the coming slides. Let us begin our journey with the intrinsic interoperability approach. So now we are hearing about chain abstraction, which is all about bringing together the blockchains of the world. And Vision Chain is aiming to achieve this chain abstraction through zero knowledge set-based approach so that users from multiple blockchains and even within the single blockchain across multiple layers like the layer 1 and layer 2 and even applications specific layer 3s, they can come together because they are exchanging the messages and events. It will be converted into zero knowledge proofs. And because it is made possible through the first of its kind zero knowledge set implementation, together with a set of smart contracts, oracles, and relayers, which are explained in this slide. When we look at interoperability, it requires the source and destination. We have to control the assets in the source and destination. Hence, we use source controller contract and destination controller contract. And proofs are generated from the source and the destination. From these proofs, the combination is generated using another proof known as intersection proof. All these proofs are monitored by a proof interception oracle. This oracle is a very secure oracle, not like the traditional oracle, because it is interacting with zero knowledge proof. And there is a relayer which takes the asset from one source to the destination. And all of this is verified by a zero knowledge verifier contract. This is explained in the diagram depicted here, where we are seeing the source chain and destination chain on the left and right side. There are asset controller contracts which will lock the assets when the user expresses their desire to do an interoperable transaction, be it staking, swapping, or payment, or any other tokenization related transaction. Once the assets are locked, the events are generated by the smart contract. From the events, proofs of activity will be generated, and these proofs will be monitored by the relayer contract and relayer service. Using this source proof and destination proof, zero knowledge set combines them together and generates intersection proof. There is an oracle which will monitor the proofs, the zero knowledge intersection proof, and will notify the verifier. The verifier will verify the proof and inform the relayer to transfer the asset from source to destination. This approach is explained for a scenario here. Cross-chain intent. A cross-chain intent where the user wants to transfer the asset from source to destination. First is liquidity locking on the source and destination. Once the liquidity is locked, the controller contract on the source and destination generate hashes of the asset and events. Then the zero knowledge proof is generated. The oracle listens to the proof and inform the verifier contract. The verifier verify the proof and inform the relayer. Relayer works with the intent handler contract. We will understand what is intent in the next section shortly. Once the relayer monitors the events, the relayer controller takes over, and then the transaction, the intent-based transaction will happen. So as we see here, the intersection proof is a novel approach from Vision Chain, which is the combination of source proof and the destination proof. And this can work across different blockchains and different layers, be it between Ethereum and Solana, or be it between Arbitrum and Polygon. This intersection proof will work in a seamless manner. And likewise, the proof intercept oracle. As we understand Oracle is a component that gathers the data from sources. And this Oracle infrastructure will listen to the proofs and will become the data source for proof welfare contracts. So this is our novel interoperability approach. Let us now understand what is intent and how we are enabling intelligent experiences using combination account abstraction and intelligent solver selection system. What is an intent in a nutshell? Intent is the expression of the aims and aspirations of users, because the users comes with desire. They are not completely aware of the end-to-end components of a blockchain, and they are not supposed to know it. Intent can encompass various goals, be it transferring assets, staking them, or taking loan, or participating in a game or an auction, anything of that sort. So here, all the type of experiences are defined as contracts, and then they will be connected to a set of solvers. Solvers are protocols and people and programs which has defined workflow for executing the user intents. Thus, intents need solvers, and they are set of algorithms. But what is happening in the current intent protocols are there are not sufficient solvers to execute intents. And we have come up with an approach to solve it. We have created dynamic auction method, which is very beneficial to people, programs, and protocols. The solvers participate in dynamic Dutch auction, and these auction methods in Dutch auction, what happens is price starts high and decreases with time. So whoever solver solve the intent or come up with a solution faster, they will get better rewards. And the solvers who has maximum availability also get another incentive. This ensures that the availability and efficiency of the intent solvers are maximum, and those solvers get rewards. Now, in addition to this, we are enabling these solvers with artificial intelligence through our unique approach known as semantic intelligence. Solvers will listen to AI generated, large language model generated knowledge graphs. These knowledge graphs are generated from the user intent, and the user intent data will be stored on a vector database, and a graph neural network, a large language model based graph neural network, will listen to this intent and generate the knowledge graph. This knowledge graph can be used by the solver to come up with innovative solutions for the user intent. And then let us see this in a diagram. The user sent their intent to a mempool. That mempool we have designed as a very scalable and very efficient mempool through something known as directed acyclic graph, which we will see in the next section. The user intent is coming into a mempool. The solver, protocols, programs, and people, they will subscribe to the intent. Then the solver will participate in a dynamic Dutch auction. Based on the result of the auction, the user select the solver and decide to execute the transaction. So intent execution begins now. And intents are executed using a paradigm known as account abstraction. In this paradigm, every account is a smart contract. Instead of using the basic accounts, externally owned accounts as in the traditional blockchains, smart contract based accounts are way more powerful because you can add validation logic, You can add additional digital signature schemes. You can add paymasters. All these capabilities comes with account abstraction. And we can also batch transactions into groups and save the fees. And you can recover your wallets in case of losing the private key because it enables multi-signature and multi-party computation schemes. And it also helps us to enable social recovery, social login. All these features are enabled through the combination of intent and account abstraction. And through this approach, we enable modular account. So in this modular blockchain, in the vision chain, we have modular accounts. Then we use a component known as bundler. Bundler is the service bundle or group the transactions, and they will work very closely with the solver. So this bundler engine aggregate transactions from the intent into a single one, and it reduces the need for broadcasting individual transaction to the group because it bundles it, and it reduces the network congestion in the wallet side itself. The bundlers can also prioritize transactions based on urgency of fees, thus making the transactions more economical and more interactive and more efficient. And we mentioned about paymasters. Paymasters can handle the fees and eliminate the need for users to manage complex fee structures and getting worried about volatile gas prices. And sometimes this is very efficient for in transactions like games, like lotteries, and different other use cases where we have large number of users, maybe social networks, maybe money streaming. All these use cases, paymasters are going to be very, very useful. And the payment can also be done in different kind of tokens. The native chain token or other cryptos, NFTs, fiat can also be used by the paymaster. So this sums up the section on our intelligent interactive experiences. Now let us try to understand how Vision Chain is quantum safe. What are the quantum challenges to blockchain? There is an algorithm known as store algorithm, which is an algorithm which can break conventional cryptography like the RSA, Diffie-Hellman, or elliptical cryptography, because it has the ability to factorize prime numbers and solve discrete log algorithm problems. Because these intelligent prime number factorization and discrete log algorithm solving problems are at the root of public key cryptography. So what happens is from the public key, if a quantum computer is having Shor algorithm implemented in it, from the public key it can infer the private key. All of us know what will happen if the attacker knows the private key. They can drain the account, they can drain the wallet and get the entire money, entire fund in a wallet. This is the threat from a quantum computer in Shor algorithm. And this is depicted in this diagram. Once the attacker listens to a public chain and get the public key, from the public key they derive the private key. Using the private key, they can drain the wallet in no time. And to solve this problem, the worldwide cryptographers have looked at various options. They understood RSA, Diffie-Hellman, and elliptical curve are not safe. And they have done competitions worldwide and shortlisted 5 to 6 techniques known as lattice-based cryptography, code-based cryptography, hash-based cryptography, isogenic cryptography, and multivariate cryptography. And later what happened is, in this program, they have understood the security of isogenic cryptography and multivariate cryptography are doubtful, and realized the top three contenders for quantum safe cryptography or quantum resistant cryptography are lattice-based approaches, code-based approaches, and hash-based approach. Among this, lattice-based approach has proven to be the most efficient and most scalable approach. So, Vision Chain has adopted lattice-based cryptography inside the consensus, sharding, and data availability layers. We will understand how it is implemented in the coming slides. So using lattice-based cryptography, the leader election in Vision Chain is executed, the shuffle sharding is executed using lattices, and the data storage, the data availability from Vision Chain is again using lattice-based cryptographic technique called as homomorphic hashing. So what is lattice-based cryptography? Lattice is nothing but a geometrical arrangement of vectors. It's a set of linear integer combination of basis vectors. As you see in this diagram, it's an infinitely long multi-dimensional grid. And in the grid, there are certain problems like finding the shortest vector, which is very, very difficult, even for the quantum computer. Because this vector is designed in such a way that even if you change a single vector arrangement, the entire lattice topology or entire lattice grid will be affected. Hence, the shortest vector in this lattice is a very, very, very formidable problem. And together with this, we have combined verifiable random functions. To generate verifiable random functions, we are passing in along with public and private key. So the output of the verifiable random function is a random number. And this random number can be verified using zero knowledge proof. This is all about verifiable random functions. And we have combined them together using a technique known as lattice-based verifiable random functions. In lattice-based verifiable random functions, what happens is when we pass the secret key, the public key, and an input, the lattice-based mathematical function generate the randomness. And this can be verified using the zero knowledge proof. This is the novelty. And this is used in our consensus, sharding, and our data availability layer extensively. So let us understand how this post-quantum cryptography is used in Vision Chain. So Vision Chain achieves single secret leader election and shuffle and state sharding and data availability proof using the lattice-based VRF. So what is single secret leader election? Single secret leader election is all about selecting a leader from a group of participants by using a shared randomness element. So every participant need to compute randomness meeting a threshold criteria. Whichever node, whichever participant solve this problem is able to become the leader. And it's all about, they have to compare with the shared randomness. So everyone knows they don't need to share the value because everyone has the verifiable random function with them. And everyone knows how to verify the randomness. So whoever computes it, it becomes, they don't need to share it. So this is way more efficient than the proof of work mechanism used in Bitcoins and proof of work big chains. And the leader is secret only when the leader want to explain, the leader can remain hidden unless they chose to reveal themselves. So this is secret leader election. What is the benefit of single secret leader election? Because the leader is discrete, is secret. An attacker doesn't know who is the leader when the consensus happens. And it is secure against distributed denial of service attacks and denial of service attacks. And because the technique uses random functions, verifiable random functions, which everyone has a share of it, the leader and the other nodes doesn't need to communicate extensively. The number of communication rounds is very, very less compared to other consensus mechanisms. It is reduced to a single round of communication. And then it can work with large number of participants, because even when the number of participants increases, we are only selecting a single leader in each round. So this is highly scalable. The communication round is very less, and it is very secure, because an attacker doesn't know who is the leader in the time of consensus. And we are using a mempool known as directed acyclic graph-based mempool, as we are seeing in this diagram. This is a mempool where every edge represents the transactions, and this allows parallel processing. You can process transactions in parallel, and the transactions are ordered in a parallel fashion, not in a linear fashion. And another benefit is, since they are ordered parallelly, and since the communication is parallel, the communication and ordering can happen separately. And this is a huge achievement, because traditional linear mempools, UTXO-based mempools, blockchain mempools, the transaction broadcasting and transaction ordering are coupled together. Here, this can happen in a separate fashion. So the benefit is that directed acyclic graph-based mempool can scale horizontally. You can add more nodes, and it will increase your parallel processing capacity. And because it can handle large volume of transactions, you can alleviate network congestion issues. It can handle network delays and outages better, because it's not based on linear ordering. And yes, we are arriving at proof of visibility. The proof of visibility is all about the combination of leader election and the proofs. So here we are using the combination of the random proof and the range proof we have generated earlier. And at the heart of it, it is all about something known as time lock puzzle. This puzzle makes sure that the data proof is shared, is visible only after the randomness proof is verified by everyone. And it is verified by validator nodes. You can run the Vision Chain validator node even on a mobile device. That is the scalability of Vision Chain. Now let me quickly summarize the approach by just showing you one more section quickly. It is all about Merkle tree. Merkle tree is an enhancement over the traditional Merkle tree based approach. And it will help you to reduce the computation cost significantly, because it can scale and expand faster than the traditional Merkle trees. And using the Merkle tree, we implement shuffle state sharding. Shuffle is implemented using randomness, which we have generated in the earlier section using lattice-based approach. And these shards communicate with each other through the Merkle proofs, and it makes sure the communication is secure. And let me summarize the Vision Chain technology. Vision Chain is bringing together leader nodes for consensus, validator nodes for verification, prover node for interoperability and consensus, sharding nodes for storing the blockchain states in a very lightweight manner, data availability node for securely storing the entire proof, and the intent solver nodes for executing the intent, and bundler nodes for account abstraction. So this is a completely modular blockchain protocol system. That with this slide, please let me summarize the Vision Chain technology. Thank you so much, all of you, to listen to my presentation. I'm looking forward to hear from you. Please share your questions, comments, reviews. We are looking forward to your support. Thank you very much.
유익한 말씀을 전해주신 우리 고쿨님께 다시 한번 멀리서 계시지만 큰 박수로.
Thank you so much, Google, for your presentation.
Pleasure. Pleasure.
우리 고쿨 CTO님에 대해서 잠깐 설명을 드리겠습니다. 그 세계 최고의 컨설팅 회사에서 디렉터 이사직을 맡고 계시고요. 전 세계 블록체인 프로젝트들을 분석하고 평가하는 일을 해오는 대단한 인재십니다. 글로벌 최정상 블록체인 프로젝트의 기반이 되는 최고 수준의 기술 설계를 통해서 지금 현재 비전 체인에 생명을 불어넣고 있으면서 비전 체인이 극강의 상호 운영성, 아까 말씀을 들으셨겠지만 상호 운영성과 최고 수준의 보안성을 가지도록 기술적 우위를 보장한 글로벌 넘버원 블록체인 전문가입니다.
To give a brief introduction about Google Alex, he has been a director at a top consulting firm and has analyzed and evaluated blockchain projects worldwide. Google knows exactly the latest technological trend in blockchain and what technical design is needed to create the best project. As the leading blockchain global expert, he has breathed life into Vision Chain through cutting-edge technological design and ensured the technological excellence of Vision Chain with extreme interoperability and the highest level of security.
이제 다시 우리 그 프로젝트의 경쟁력을 이제 분석해서 또 이야기해 주실 우리 비슈아 CEO님을 다시 단상으로 모시도록 하겠습니다.
Now, let's invite CEO Vishwa back to the stage to analyze the competitiveness of our project.